Telegram lets you add two kinds of proxy, MTProto and SOCKS5, and the app barely explains the difference. Pick the wrong one for your situation, and you either can't get past a block or your account looks suspicious. They solve different problems. This video makes the choice obvious, with the protocol facts, the link formats for both, and the clear rule for which to use when. I run managed Telegram hosting and proxy infrastructure on dedicated hardware in Singapore, so I set up both of these constantly. The short version up front. Use MTProto when your goal is beating a network block or censorship. Use SOCKS5 to a real mobile proxy when your goal is controlling what IP your account appears to come from. Now let me show you why, because understanding it means you'll never pick wrong again. Start with what each one actually is at the protocol layer. MTProto is Telegram's own protocol, named after the encryption it uses, and the proxy version is purpose-built for Telegram and nothing else. It doesn't carry your web browsing or any other app, only Telegram. The important part is the modern factors mode. It wraps your connection so that to any network equipment, inspecting the line, the traffic looks like an ordinary HTTPS handshake to a normal website. That's a deliberate disguise designed to defeat deep packet inspection, the technique sensors use to recognize and block Telegram traffic by its signature. SOCKS5 is the opposite kind of thing, a generic decades-old proxy standard that tunnels any TCP connection through an intermediate server. It isn't Telegram specific at all. It'll carry Telegram, a browser, a scraper, anything. It makes no attempt to disguise the traffic as something else. Its whole value is in where the exit point sits. When that exit is a real phone on a real mobile carrier. The IP your traffic appears to come from is a carrier-grade NAT address shared with thousands of legitimate mobile customers, which is extremely hard for anyone to block without hurting real users. So here's the first axis, censorship resistance. On an aggressive network that's actively trying to block Telegram, MTProto wins, because the Factos disguise is built specifically to look like innocent web traffic. SOCKS5 makes no such effort, so a network doing deep packet inspection can often spot a SOCKS5 tunnel and the Telegram traffic inside it, and block it. If you're in a country or behind a firewall actively fighting Telegram, MTProto is the tool. Second axis, IP authenticity. This is about how your account looks to Telegram itself, not about getting past a block. MTProto proxies usually run on data center servers, so even when the connection gets through, the IP your account appears to use is a data center IP. For simply reading messages past a block, that's fine. But if you care about your account appearing to come from a normal mobile user, a data center IP is the opposite of that. A SOCKS5 proxy pointed at a real mobile phone gives your account a genuine mobile carrier IP, which is what looks normal and trustworthy to Telegram. So for IP authenticity, SOCKS5 to a mobile proxy wins clearly. That's the whole decision in two axes, beating a block, MTProto, controlling your apparent IP toward a clean mobile address, SOCKS5 mobile. And the two aren't mutually exclusive across your accounts, they're just different jobs. There is a third axis worth naming, who has to run the thing. MTProto proxies are something you can stand up yourself cheaply, a single binary on a $5 VPS, as I've shown in another video, and that's part of their appeal for beating a block. You control the endpoint. A real mobile SOCKS5 proxy is harder to self-provide because it requires an actual phone on an actual carrier, which is a physical thing you either own or rent from a provider. So MTProto leans toward do-it-yourself, and mobile SOCKS5 leans toward a service relationship, simply because of what each one physically requires. That's not a quality difference, it's a logistics difference, and it often decides which one a given person ends up using. And the fourth, what they cost in latency. MTProto adds one hop to a data center and tends to be fast. Data center network paths are quick. A mobile SOCKS5 proxy routes through a phone on a cellular network, which is genuinely a little slower and jitterier because mobile networks are. For messaging, neither difference matters. For voice calls or large media, the data center path of MTProto can feel snappier. So if raw speed past a block is all you want, MTProto is also the quicker option, not just the more disguised one. Let me make the mobile proxy claim concrete, because it's the part people don't verify. With a SOCKS5 mobile proxy, you can check the exit IP and carrier with one command. You run cur, then -x, then SOCKS5h:// then your username: password, at the proxy host: port, then a space, then https://ipinfo.io/json. That returns the IP, the org, and the country it's coming from. You want to see a real carrier name in the org field, something like Singtel, M1, StarHub, or Vivify, and country SG. That SOCKS5H scheme matters. The H forces DNS lookups through the proxy too, so you don't leak which sites you're resolving to your local network. If you see a hosting company name in the org field instead of a carrier, it isn't a real mobile proxy, no matter what it was sold as. Now the link formats, so you can enter either one. An MTProto proxy is shared as a link reading tg://proxy server equals the host, ampersand, port equals 443, ampersand, secret equals a long hex string. That secret is the key part. In facts mode, it also encodes the domain being fecked. There's a web version starting with t.me/proxy that takes the same three values. A SOCKS5 link reads tg://socks server equals host, ampersand, port equals the port, then optionally ampersand user equals and ampersand pass equals for authentications. Its web version is t.me/socks. Tap either link and Telegram offers to edit, or enter the fields by hand under Settings, Data and Storage, Proxy, Add Proxy, choosing the matching type. Now the edge cases, because each protocol has its own. For MTProto, the secret format is everything. There are older secret styles without the Fractal's disguise, and on a censored network those get detected and blocked quickly. You want the modern hex secret with the fact domain baked in, the long one. If your MTProto proxy keeps getting blocked fast, an outdated secret format is the likely reason, not the server itself. For SOCKS5, the classic mistake is the DNS leak. If your client resolves domains locally and only tunnels the connection, your network still sees what you're reaching. Inside Telegram, this is handled, but when you test with curl, use SOCKS5H, not plain SOCKS5, so DNS goes through the proxy, and verify the exit with that IP info check before trusting it. Artisan's SOCKS5 trap, IP authentication versus user pass. Some mobile proxy providers don't give you a username and password. Instead, they whitelist your home IP and let you connect without credentials. That works until your home IP changes, which it does, and then the proxy silently stops accepting you. If your SOCKS5 proxy worked yesterday and won't connect today with no settings changed, check whether it's IP whitelisted and your address rotated. Switching to username and password auth, if the provider offers it, avoids that whole problem, because then your credentials travel with you regardless of which network you're on. There's also the question of trust in whoever runs the proxy. With either type, the operator can see your connection metadata, which servers you reach and when. They can't read your Telegram messages. Those are encrypted between you and Telegram, regardless of the proxy. But a malicious MTProto proxy can do one thing a SOCKS5 proxy can't. It can attach a sponsored channel that appears in your account, and some free public MTProto proxies do exactly that to monetize you. So if you grab a public MTProto proxy and suddenly see a channel you didn't join, that's the proxy, drop it. A proxy from someone you trust, or one you run yourself, doesn't have this issue. This is a real reason to prefer a private endpoint over a random public one, regardless of which protocol you choose. A shared edge case, voice and video calls. By default, Telegram calls connect peer-to-peer and can reveal your real IP to the person you're calling, bypassing your proxy. Both proxy types have a use for calls toggle in their settings. If you want calls hidden behind the proxy too, turn it on. If you only care about messaging, leave it off for slightly lower latency. Another point, you can keep both kinds saved and switch. There's nothing stopping you from storing a private MTProto endpoint for when a network is actively blocking, and a SOCKS5 mobile proxy for when you want your account on a clean carrier IP, and flipping between them per situation. Telegram remembers both. On a bad day, having both saved means recovery is one tap instead of re-entering credentials. One honest limit to state plainly: neither proxy changes your device fingerprint or how your account behaves. A proxy moves the connection. It doesn't change the identity carried in every session. So if you run Telegram on a desktop client through a mobile SOCKS5 proxy, your account still fingerprints as a desktop on a mobile IP, which is a mismatch that's detectable. The proxy is one layer. For an account that genuinely needs to look like a real person on a real mobile device, the connection, the device, and the behavior all have to line up, and a proxy only handles the connection. That full alignment is what we run. Manage Telegram hosting and proxy infrastructure on dedicated hardware in Singapore, where the account lives on a real device with a real Singapore carrier IP. So the connection, the device, and the IP all match instead of fighting each other. If you've hit the limit of what a proxy alone can do, start at telegramvault.org and use code TGYT. But if you just need to beat a block or put one account on a cleaner IP, the right proxy from this video does the job on its own. There's no shame in using the simple tool for the simple job. So the rule, one more time, MTProto with a modern factory secret on port 443 when you're beating censorship or a network block, because the disguise defeats deep packet inspection. SOCKS5 to a verified mobile proxy, checked with that SOCKS5 H curl call when you want your account to appear on a clean real mobile carrier IP. Keep both saved, mind the calls toggle, and remember the proxy moves your connection, not your identity. If you are still unsure which you need, ask yourself the one question that settles it. Is my problem getting through, or is my problem how my account looks? Getting through is MTProto. How the account looks is SOCKS5 mobile. Almost every real situation falls cleanly on one side of that line, and when it falls on both, you keep both saved and switch. That's the entire decision. And now you can make it in 5 seconds instead of guessing. If this helped you pick, subscribe, because the next video is a full troubleshooting guide for getting Telegram working on restricted networks. The exact order to try things when nothing connects. Thanks for watching.